Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. Relational databases continue to be a huge part of modern system design, and the rules of relational databases should generally be followed. However, there are times that you need to bend or even break normal database design rules in order to reach your goals. When I say that, I think of the Matrix.
Yeah.
In this episode, we're going to talk about some of the times you might want to avoid being perfectly compliant with the rules of relational database design. But before we get started, Will, what have you been fighting this week?
Well, I have the book cover for my book. I think I sent that to you, didn't I?
You did. It looks really awesome.
Yeah, it does. It's way cooler than the previous one.
I would see that on the shelf and pull it out to look at it.
Yeah, and that's the idea, right? Because you can actually judge a book by its cover. And I had to go through the whole book proof thing. So looking at page layouts for 268 pages. Going all the way through that. And now we're kind of working the marketing plan and, all that stuff. So you're going to be hearing a lot more about that book. Well, actually, you probably already have because we're recording ahead of time. And so the marketing shenanigans are going to begin very soon. So yeah, that is what I have been dealing with on top of the whole, what is it? House arrest without trial that we've got going on in the US right now. Which, it's like, that has piled a whole lot more stuff on me right when I have almost more work than I can do.
Yeah.
And it's been very unhelpful, but we'll get through it some way or other. So how about you?
So big happy birthday to Amanda. This episode is coming out the day after her birthday, and I know she listens. She might be listening a day or two later, but just a straight up happy birthday to her. I'd sing, but nobody wants to hear that.
Yeah, I think that's like you singing would be the anti-birthday present.
I know, right? I've gone to people's parties where they're like, "Oh, don't bring me a present," and somebody brought a card or something, and when we sang to him, I was like, "My present to you was not singing."
Yeah. In fact, what you should do is you should find the time of year that is 182 and a half days from her birthday and then sing to her on that day. Because that's like her anti-birthday.
Her unbirthday?
So what?
Her unbirthday?
Yeah, her unbirthday. Is that what they call that?
Well, she's a big Alice in Wonderland fan. So, yeah.
Okay.
So, yeah, we will, Amanda, in 6 months, we will celebrate your unbirthday.
Yeah, I would totally troll you or something.
Oh, you totally should do that for mine too, because that would be really neat. But we won't go into that. So guess what? The church bought a new computer for streaming. This is really cool. It's so exciting. Especially since I got to be involved in the process, like the decision making process, and I was one of the two people who was tasked with looking at computers. So I spent a week or so looking at computers, comparing them, talking to the other person who was looking at them. And we were just going back and forth about it. It was so awesome because I got to spend someone else's money. We had been using the pastor's personal laptop because it was powerful enough to run the stream from. But the other computers we had just weren't. They're older and stuff. They're good for what we were using them for, but just not strong enough to do that. Honestly, if our pastor had been born in a different era or under different circumstances, he'd totally be a techie. I mean, he's got the aptitude for it. We sat and talked about things. I made some updates to the church's website recently. They gave me admin access. It's a WordPress site, so I was able to get in there and, I'm familiar with WordPress and make some changes so that we could stream on it. And he was asking me what I did, and I was trying to give him kind of an overview, and he started asking more and more detailed questions. And so I got as nerdy as he would go with it, and he followed along. I was impressed. I'm not used to people outside of the tech community
Nice.
being that knowledgeable. So I was like, hey, this is something we can talk about on top of motorcycles.
Yeah.
So that was really cool. Now, while I was researching stuff, I looked into Macs because there is a very common church software called ProPresenter that's for pushing slides and stuff up to it's designed for worship and sermons and stuff like that. We used it at all the churches that I have been at the last few years, all of them too, both churches I've been at. But it's a very common thing for doing that. And it was originally built for the Mac. And so I was looking into a Mac Pro, found out they have a new Mac Mini. Like they haven't had a new one come out in a while. And the base model is a little bit better than my personal laptop. Like the specs on it, like a little bit better processor, same amount of RAM, a little bit more memory, hard drive space, SSD. And, y'all have been looking. I've been thinking about getting a MacBook for my next machine because I'm definitely not going Windows ever again. I say that now, but, we'll see what happens. But
we'll see what happens when your mouse only has one button.
Oh, hey, I've got a Mac for my personal or my work laptop I've been using for years. So yeah, I'm fine with that. But I was looking at it and I'm like, you know what? I think I'm gonna get a Mac Mini. It's a little bit less expensive than the MacBook, at least the one that I want. I still want to get the MacBook, but I might wait on that and get that Mac Mini for my main machine here at home, and then might spend a little bit more, a couple $100, and get myself a Chromebook or something just for travel and stuff.
I've thought about getting a Chromebook just for writing. Instead of having to deal with Windows and worry about all that stuff, just have it, have the stuff in the cloud and be done with it.
Yeah. That's what I'm thinking about right now. Dude, I have so much beer. I mean, not only the stuff from Amanda.
It must be horrible for you.
Oh, awkward. Yes. It's horrible. Oh, it's just... They've been doing a lot of deals out at Mill Creek, and since she gets an employee discount, she's been buying a lot of beer when it goes on sale. But in addition to that, we've been going out to local breweries. I think I talked about this last week, where we're trying to support the local businesses, especially the ones that are kind of outside of the major areas. And so we'll go out and we'll buy some beer from each one of them when we go visit. And it's a nice little outing once a week to go out to some place. And actually, I'm compiling a list of places I want to go when the Rona is over.
Yeah.
Yeah, I called it the Rona. I've been compiling a list of places I want to go. Actually, I was talking to a friend of mine who just bought a motorcycle right before all this hit. I'm like, hey man, when all this passes, I've got, like, he likes beer too. So I'm like, let's do a beer run where we go, like, we'll probably start up at Calf Killer in Sparta and ride. Like, we might start out, I think there's one out in Lebanon close to where he lives. So I'll meet him over there. We'll ride to Sparta. We'll ride out to McMinnville, then to Columbia, and then maybe end up at Mill Creek there in Nolensville, and just sort of make this sort of round, like the outskirts of town trip. There might be a few others I add to it. Just make it a whole day thing. Start when they first open and like go have a beer at each one, something like that. That just sounds like so much fun and such a fun thing to do when all this is over.
Yeah.
That and getting a tattoo. I really want another tattoo.
I think I might just like go somewhere really isolated.
Get a tattoo?
No. Like go somewhere really isolated and like camp. Like be isolated and like stuck by my own choice.
Yeah.
And on the way, like I'm going to stop and I'm going to sit down at a Mexican restaurant and I'm going to have margarita and chips.
Oh my goodness.
Inside the building. And I'm going to sit less than 6 feet from another human being.
Dude, I tell you, I was craving margaritas the other day. I got one from the restaurant bar underneath Amanda's apartment. And it was, well, they were being nice because I'm somewhat of a regular there. So they made it really strong, which I appreciate. But I just wanted a straight up margarita, not like tequila with some,
with some lime juice in it.
Yeah. So I bought some like pre-mixed margarita and I'm like,
it's not the same.
It's not, but it was enough to hit that craving. So, but dude, like I was saying, I have so much beer that I was craving something else. Like, I wouldn't exactly say I'm hoarding beer or coffee. I have a lot of coffee too.
I do too. I'm scared to death of running out of that.
Yeah. I could throw a pretty rockin' party right now. Let's just say that. Honestly, my fridge is full of leftovers and beer. It's kind of just like college and grad school and med school.
After college.
I'm kind of noticing a trend here.
Yeah. So, it seems like constants aren't surprises.
Yeah. Also, I've been walking the dogs a lot, trying to get as much exercise as possible with all that beer I've been drinking. Actually, I've been getting back into kettlebell swinging.
Yep. Same here.
Kind of got away from it. Yeah, I got away from it when I stopped coming over to your place to work out before we recorded and other times of the week. I need to clean out my garage a bit. I've been going outside to work out, but I need to clean that out so I have a place to swing when I'm not when it's raining and stuff and I can't go outside. So, but with all of that, let's go ahead and get on into book club.
Chapter 7 of Remote Work, The Complete Guide by myself, truly. I don't know how you phrase that, is creating good habits to remote work. In the previous chapters, we talked about mitigating some of the downsides of remote work. But if you're going to do it over the really long term, what you really want to do is have it actively improve your life. And the way you do that is through the creation of habits. So in this chapter, I work through some of the biggest issues that you're going to face in regards to remote work. This is stuff like your diet and your exercise, and are you avoiding isolation properly? Like, not just, hey, I'm talking to people at work, but like actually getting out and participating in society on a regular and recurring basis. How you manage home interruptions and how you build strategies around that so that you don't get interrupted all the time when you're trying to work. Dealing with interpersonal issues, those kind of things. Basically, the deal is this is somewhat of a small course on habit formation and how to think about your habits when you're working remotely so that they help you instead of hurt you. Mm-hmm. And we'll have a link to that in the show notes. Who's talking to us this week?
So we have an iTunes review from H. Jeezy. He says, "Great developer podcast. I'm a data analyst that does some work more toward the developer end of things. This podcast provides a good balance of information. I especially like the episode where you forecast for the coming year in tech." So thank you so much. That's one of our favorite episodes to write.
Yeah, but this year.
Yeah, this year's a bit different. I'm going to update my predictions right now.
Yeah, like retroactively.
Yeah. No. We're early enough in the year. I can update them. Remember when we did the update in June? Hey, we ought to do that. That'd be a good episode.
I think that'd be a good idea. If this is over by then, definitely do that and talk about what we learned from the Rona.
Yeah. So I'm going to update my predictions and say that we're going to see an uptick in virtual conferencing options and companies making medical equipment.
Yep. And people buying storage for food and toilet paper. And
yeah,
I honestly think toilet paper is the new coin of the realm.
Well, I will say this. I have seen images of people trying to return all the stuff they hoarded, and
they can't.
Some stores are not allowing it.
Yeah, Costco won't let them because it could be contaminated. It's been in a house. You don't know where it's been.
Oh, that's right. And I mean, I think
it's mainly out of spite, but that's a good reason too.
Yeah. So send us an email to waterbottle@completedeveloperpodcast.com because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review on iTunes or comment on the website or any of our social media. We post all our episodes to Facebook, LinkedIn, and Twitter. We're also on Instagram and Tumblr. I should post some Instagram photos of the trips and stuff that Amanda and I have taken. Maybe, hey, you know what? I don't know what it's going to go on at the time this episode comes out, but I'll post some stuff, whatever that I end up doing for her birthday. I'll post that for you guys. Now, you can join the conversation anytime via Slack by going to slack.com podcast.completedevelopernetwork.com. Your advertisement could be here. I haven't done that voice in a little while. It's kind of fun.
Yeah, it's kind of weird.
Yeah. If you like the show and would like to advertise, send us an email to adverts@completedeveloperpodcast.com. We have short-term, long-term, and other sponsorship opportunities. Reach out to us and let us help you reach the people you are serving during this time of quarantine.
So when I started software development professionally and had to deal with relational databases, the rule I was given when you design these is to normalize the database until it hurts and then denormalize it until it works. So it's basically like over tightening something and then easing off a little bit. That's kind of the way that was expressed.
Yep.
While normalizing a database is a solid practice, and we have an episode about that, and it is something you should do when you're designing a system, it can really jump up and bite you when you start getting under load or you start having changing requirements or certain kinds of weird requirements in your app. You're probably not going to deal with most of these when you initially design a database, but you'll find that you run into them as the app matures more than anything else. Eventually, some degree of denormalization is going to be necessary if your system is successful, mainly just to keep performance up to snuff.
On average, if you start suggesting denormalizing a system, you'll have to be able to show that it improves performance significantly. There are good reasons that systems aren't denormalized, and people will typically balk at doing so. However, there are places where, under some circumstances, it's worth considering, and in some places, it's necessary. After all, CPU cycles on a database server are often some of the most expensive ones out there. Like, go check your SQL Server or Oracle license fees for more proof on that. Seriously.
Yeah, especially SQL Server. Like, you have to get a master's degree in SQL Server licensing before you can understand the freaking table. Yeah, it's like, oh, I don't know what it costs, and nobody else does either.
Okay, so I've got to be honest before we get into this the outline here. When you told me you were doing an episode on breaking relational databases, I thought you were talking about like NoSQL and document DBs and like when to go with those versus when to go with relational.
Well, it's interesting that you bring that up because a lot of this is how you hackily make some of that stuff happen in a relational database because that's your main system.
Yeah. Yeah.
And a lot of times what will happen is you'll denormalize for a little while and that won't necessarily work out as well as you want. And you end up with a document database off to the side with some of the stuff in it, or, a graph database or something like that. It tends to be a process that occurs over time.
Yeah. The reason I thought it was like, it may be because we're looking into document DB options for some of our solutions. And so I was like, ooh, this would be really cool for like, why does it do this versus other times? But I also really like this because I tend to be one of those people who is over normalizing things because,
because you're not normal and you got to compensate.
Yes, exactly.
Yeah. It's you're in your third normal form, not your final normal form. Is that what that is?
Oh, they like that. I like that a lot. That was good. That was good.
Yeah, you go to all the restaurants and join the tables. Wait,
what?
The dad jokes are just. I'm telling you, man. The quarantine is going to make the dad jokes so much worse. It's not good.
I will say this. That does remind me of high school because I did literally my senior year. I walked to lunch with one group of people. I ate lunch with another group of people. I went and sat with another group after eating lunch, and then I walked back to class with a different group.
Yeah,
because I like people. So I joined all the tables.
Yeah.
So anyway,
there you go.
All right. So let's get into this. First off, when additional join tables will hurt performance. So wait, before we jump in, I'm guessing this is times
when you would do it, when you would consider it.
when you would consider denormalizing. So the first one is you would consider denormalizing when additional join tables will hurt performance.
Yeah. Turns out that joins are not cheap or free.
True that, yo.
Especially when you have big tables and like there's a lot of data in both of them, or you've got a table that's hot, that's getting hit by a lot of stuff, and it's getting written to, and you're trying to read from it with a join, and you're getting locks. It can really pile up very, very quickly. Complex joins in this particular case will be especially bad. So if you have a function call in a join, for instance, in the join statement.
Oh, yeah.
Like where it can't optimize with an index, not good.
You ever had an issue where you're getting like duplicates on your joins? Like they're not duplicate rows, but on the like actual data, but the join table has them. I'm facing an issue like this right now. That's a bug that recently came up.
Oh, where like you're joining to a child table and it's got multiple instances of similar rows that that are attached to the parent.
Yeah,
but you got to do a group by, but you can't quite because you can't tell which one's the right one.
Yes.
Yeah. Yeah. That happens a lot. That's one thing with the relational model. Like if you have something that's a one to many for whatever reason, it's one to many for all the reasons. Mm-hmm. And a lot of times you can't restrict that. And stuff will get in there sometimes, especially over 10 or 12 years, and you have no idea how it got there. You have no idea what's using it. You don't know what reports are pulling from it. You can't screw around with it and you're stuck. It's also like joins get expensive when they go across a lot of tables and they start doing a lot of aggregations as they go over, a complex object hierarchy. So it's like, hey, I want to see all the invoices and I want to tie that to all of the sales managers and their people and break it all down and figure out who made the most sales within 50 miles of where they work in the entire organization. And I want to reward them and their manager and their manager's manager. Like you get these kind of weird, like crazy join situations, and the relational model does not help you deal with that. Mm-hmm. It actually will a lot of times create situations that really, really hurt you as far as performance. The other thing is when you're aggregating a lot of stuff, it a lot of times tends to be kind of a reporting type purpose, or it's reading out a document, or it's something along those lines. And if that data underneath doesn't change, you're wasting CPU cycles by recalculating it.
Yeah, what I've seen,
and if you're doing that a lot,
I would say what I've seen a lot here in just like dealing with this is a denormalized view.
Yeah. And sometimes you can get away with that if you can calculate in the view and have it store it.
Yeah, if you don't have to do it like just in time, and you could do like a materialized view that's run once a day or something like that, then it's a lot nicer.
Yeah, and like old school, we didn't have that. So you made the table for that thing, and you crammed the data in with a nightly batch, and that's just how we lived.
That sounds painful.
I mean, it's like the thing about it is that the people in the Stone Age didn't realize that they were Stone Age people. They just, this is the way we do it.
Yeah. I mean, like, well, it's one of those things. It's like I've had to stop myself. Like just the other day, I was on a call with my lead developer and one of the DBAs, and they've been around for a long time. And we were talking about a system that's older than they are, but they made a lot of adjustments and stuff, and they know it inside and out. And I'm writing some new stuff that has to integrate with it. And they're telling me about like the process. And I was really confused. I'm like, why?
Yeah.
Why are you doing it that way? That doesn't make any sense. But I had to like catch myself and be like, all right.
Right.
It's because it was built 20 some odd years ago or more.
Yeah.
And they were using what they had at the time to build it.
Yeah, when you start having to deal with these complex systems, and especially when they're old, and the system is expanded, and initially they thought, oh, we're only going to use this for 2 years, and it's going to have a maximum of 1,000 records in there, and all of a sudden, instead of it being a 1 county thing, it becomes a 95 county thing, and the population explodes because we thought we were a backwater 20 years ago, and we're not now.
Yeah.
And you still have those same joins in place, it won't work at scale. And so you're going to have to start doing things. And so this is actually probably the most common one that I see. Mm-hmm. It's just too many joins, and we need to get some of this stuff sort of cached in the parent record.
Yeah.
And then we got to do some kind of shenanigans to maintain that.
So the next one is when you need to keep historical database records. Consider a system that manages invoices and products. You don't want to mess up historical data on invoices from last year when a product price changed today.
Right. And so this is actually an error that people do, because The thing is, when you're storing historical data, it is not the same entity as the current live system.
No, not at all.
It's a snapshot. But you'll always get that comp sci grad that had a database course and doesn't think ahead because he knows he's right. And that guy will do this. I mean, like I've seen it like 5 or 6 times in my career where invoices got all screwed up because somebody changed stuff and said, "Oh, we don't need these other tables. We can just move it around." And they thought they were a whiz kid and they didn't tell anybody. And you got to restore from a backup and then try to.
Yeah, I had this issue about a year or two ago when we migrated data from an older system to a new one that I had written, and the DBA who did the migration was like, "Oh, this is the same information like so like we'd have these rows in the database that represented things that had been like inactivated, but they needed to keep them for historic reasons."
Right.
But it had like, it would connect to the same, it would have some of the same information across them that we had consolidated onto a table. So they would put they would put one row with that information and then have them all point to it. I'm like, no, I told you when we built it, that was not like that they each had to have, like, it was literally a 1-to-1. It had to be 1-to-1. It couldn't be 1 to many like that, or many. It would actually be a many to 1.
Right.
But it couldn't be that way. It couldn't be like, all right, one child for multiple parents. It was like, it had to be one child per parent.
Yep.
But they didn't, but it was easier to write it that way on the migration. So they did, and had all these problems, and they were going in and manually changing it. And I was like, this is where the problem is. You need to go in and actually just redo the migration and fix that. And it wasn't until someone in upper management came down on them and said,
"Yeah, what are you doing, bro? You're supposed to be a DBA."
Yeah.
Like this is, I don't think I've ever seen a DBA make this mistake, but I've seen devs do that, especially if they don't understand business and reporting requirements.
And that's what it was like. And it was just one of those things where they didn't understand the new way that we had done that.
Yeah. So speaking of historical tables, the other thing is that as opposed to your transactional tables, historical tables typically are used mostly for reads, right? Like you don't go back and alter an invoice from 7 years ago.
Yeah.
Unless you're doing something awful sketchy. Right. So that's not a thing that happens. And so you want to cut down on the number of joins because now you know what the shape of the traffic hitting that table is. Hey, I want to index the crap out of it so that queries are fast and all that. And I'm not as worried about insert performance because that's probably happening at night.
Yeah. I mean, that makes sense. If it's for historical data, then you can insert slowly. You don't need like fast inserts into this, but you're going to need to run reports on it. You're going to need to like search it. It's going to need to be a high read, low input table.
Right. And these tables will be more heavily indexed as a result of that. And so a lot of times that means that they're going to be on a different hard drive. If you're managing that on your database server and saying, hey, this one lives on this physical, this platter over here versus the transactional one that lives on this other one. You're wanting your OLTP, your online transaction processing table. That one has to be fast because it affects user behavior. People get mad. Whereas a reporting table, you don't have to insert to it as quick. So that's kind of the trick there is you just have a different profile for who's hitting it.
Mm-hmm.
The next one is, in this same line, it's when data needs to be structured for reporting purposes. So when you have a reporting system, you typically will have a lot of data duplication, especially now because storage is so cheap compared to processing. It's night and day difference. A lot of times you'll duplicate data so that you can actually see trends easier. So for instance, if you have invoices and they've got line items under it, right? You may want the invoice total on the invoice record instead of it being an aggregation of the stuff underneath, because then you can do a select on the invoices and say, hey, is this trending upward? Are we getting bigger invoices on average than we used to? And it makes that calculation easier because that data is just in one table instead of you having to do a join and aggregation and then go back and test all your stuff to make sure you didn't screw up.
So you're also going to have very different indexing requirements when you're building these reporting tables. Like I was saying before, and I think Will's talked about it too, like this is why a lot of times you do views for reporting, where you can set that up, and if it doesn't have to be done immediately, you can set it up to build that view at a certain time.
Right. And it really changes the way that you interact with it. I know we kind of talked about that previously with historical tables. Reporting tables, like historical tables, are a type of reporting table.
Yes, they
effectively. The difference with historical tables is the date management and knowing what happened when and being really specific about that from an auditing perspective versus from a generating pretty graphs and charts perspective.
Yeah. Well, a historical table needs to be a table, whereas a reporting table can be a view.
Right. In general, although a lot of times I've had bad luck trying to make them into views because of some of the systems I've worked on. But I think it's because I have a bias towards systems a lot of times that are messed up anyway.
That's because you're messed up.
That's why I'm there. So yeah, as I tend to go in those situations and I enjoy that.
Yeah,
so it may not be that way in less interesting in the Chinese curse sense situations. The way the tables get accessed is different for reporting. Again, this is read heavy. And you're probably going to do things like change the way you do locks on the table. So for instance, if you're doing stuff off of a transactional table, you don't want dirty reads, right? Because it's getting written to all the time and it's going to make your numbers be really off. Whereas a reporting table is written to once at night and read from all day. You can say, yeah, give me dirty reads. In other words, don't do the transactional locking in such a way that it slows everything down. Just give me the stuff and go on. You don't have to worry about the data getting edited while you're doing it because it's an extremely unlikely scenario.
Yeah, that makes sense. Now, the next time you want to consider breaking the relational database rules is when the data itself is hierarchical in structure. Now, hierarchical data is difficult to represent in a relational model. Oh my goodness, it is really difficult.
But it looks easy.
Yes.
And everybody does that at least once.
It looks like it's going to be like, yeah, it looks like it's going to just fit right in. And no.
Yeah.
Not at all, y'all.
Because, the problem is when you have a actual real hierarchy, not a thing that's a parent-child, but like parent-child, grandchildren, great-grandchildren, and of arbitrary depth, is that every one of those jumps is a join.
Yes.
And you don't know how many you're writing.
Yes.
And so you have to do a lot of really funky stuff to get everything acting right. And it gets slower the more rapidly the further down that tree you go. And usually the things that are the leaf nodes on a tree are the things you care about most of the time.
Yeah. So I've worked on one where it was you had parent with a one-to-many relationship for children. Each child had a one-to-many relationship with the grandchild. Each grandchild had a one-to-many relationship with the great-grandchildren.
Yep.
And there was also a few like one-to-one relationships at each level.
Yeah, because you got to also go back up too, right? Because you need to go, if I'm on this record, what is its parent? Yeah. And then you got to maintain those relationships if something changes.
So like we would have like they would want to search by criteria, like pull information by criteria on the great grandchild to get stuff on the parent.
Yep.
Or, whatever. And so we had to flatten that out into a view that was like one row in the view per great grandchild.
Yeah.
With the information they wanted to search by. And then we could use that to call back and get the whole thing.
Yeah. It's especially fun when you have to rearrange a tree and you have to write code that can handle a tree of arbitrary depth in a relational system. I've done this, by the way, with a bill of materials system, and it sucked.
Y'all can't see the faces I'm making.
It was unbelievably nasty code, and it took 6 weeks to do, and it wasn't right. And we never could get it to act right. And I've also worked in a situation where instead of doing that, what we did is every node in the tree was at the same level. And then we used a spanning tree algorithm to say where that node actually was in the hierarchy. So we could, you had a range between, what was it, -1 and 1. Mm-hmm. And basically the root node was 0. And then the left, because it was a binary tree. So we knew kind of how that one split out. And you could say, okay, well, the left one, the left middle one was -0.5 and the right middle one was 0.5. And then the children, and so you could tell where it was horizontally, and that told you where it was vertically and what its parent was, because it was a binary, and it worked. In that particular system, it worked. It was, but like when you had to onboard somebody, you go, okay, bro, this is your first day. You're not going to enjoy this. No one ever does.
Yeah.
We had to do that. And that was a way you had to break it. It gets very, very tricky when you have arbitrary depth in a scenario like that. Mm-hmm. It's also really difficult to write tree logic for structures that are in a relational model so that you don't accidentally create cycles in data. That was another thing that we did. And so we would pull stuff back and we go, okay, we'd get the whole list, with that hierarchical model, and you had a reference to the parent. It's like, well, I got the parent ID. I'll just use C# code and recursion. Right? Okay, cool. But what happens when somebody inserted a record in there, where it's got a parent and the parent's parent goes over here, and then that one points back to the first one, and now you have a cycle where you expect to have a tree and you're doing recursion. Guess what happens? What pretty things happen to web servers under a load when you have infinite recursion?
You remember? It was last week that I was talking about crashing dev server.
Yeah,
it was something like that.
Yeah, and believe it or not, we cursed and recursed quite a bit, because it was user input data, and we didn't have a validation condition, and we had to go and look in the database because we couldn't even figure out which one it was. Mm-hmm. We had like 30 tenants in there. It's like, okay, who did this? And we didn't have timestamps that were accurate on that record. Turns out, so we also didn't know which ones had been edited in the last hour.
Oh wow.
Yeah, it was real bad. So yeah, it's really hard to get the logic right where a cycle doesn't occur when you have that kind of stuff going on, because it could also, be something that's not upstream of that particular node. It could be some other, thing off to the side, and then that one goes back around. I mean, it's painful trying to do this in a relational context. So you may have to do odd things that don't make sense to people that are database purists.
Yeah. Now on that, the next one is when the data is a graph structure. It's a lot more complicated when it's a graph, because at that point, cycles are actually possible.
Yeah. And your database code now has to take that into account. And most database engines don't particularly like recursive SQL type stuff going on in there. They don't have facilities for going, how deep am I in this? It's just, it goes, okay, you got a max stack depth, and when you hit it, we obviously blow up the whole thing. It's like, well, that's not really what I needed. I needed you to say, hey, you're at the max and something else.
Well, like, while storing nodes and edges is easy enough, doing things like finding the shortest path is extremely difficult,
because you don't know that it's not going through 5 nodes to get there versus 2. If they're especially if it's like weighted edges and or weighted nodes, it's like, well, if it goes to this node, it costs as much. Or if there's multi, you're kind of almost getting into an AI type problem at that point anyway, because it's NP hard, but you just put it in your database.
I remember doing stuff like this in class last semester with the nodes and the weighted nodes. It was really cool. And with like C++, you could do stuff around that, and it was kind of neat, like determining what's the shortest path. But SQL is not quite as versatile when it comes to that as C++.
Yeah, it's not made for that.
No, it's not. That's the thing. This is a use case that is not what it was designed for.
Yeah, because their thing, back in the day, what they would do is say, okay, what you do is you have a field with a file path, And then you go out and you get that graph loaded in a serialized formatted, and you deal with it in a language that handles that.
Yeah.
Like an adult. Sorry.
That's funny.
It's also a lot of fun when you have a situation with a graph where you're trying to prove that two nodes are, or worse, are not connected.
Yeah.
Within that data set with a graph of arbitrary complexity, it does not store well in SQL. There's ways to do this in memory in non-SQL type languages, but SQL just doesn't play nice. And it's not just the structure. It's like a fundamental problem with the language you use to access that structure.
Yeah. Yeah.
So another place that you'll get bitten by the relational model and have to go and hack around stuff is when you have really large records. Now, this has gotten better with, I know SQL has done it, Oracle's done it, Postgres has done it, and I think MySQL has. They almost certainly have. But when you have huge records, whether you query them or not, the database server will often struggle. Bear in mind that the database server is not really built as a file server, right? Like there's cheaper ways to store big chunks of data if you're not indexing it. And that server is not a good place to do that because of the cost.
I will say, like, this is an interesting thing because we're actually dealing with this as we've gotten a better way of storing files. And so, like,
now you got to export from the database.
So that's not me. That's not on me.
Good dodge.
Thank you. Now I got to wrote.
You got to wrote?
I got to wrote. Yeah.
Yeah.
I can't speak tonight. I got to write the really cool app that works as a background service for scanning paper documents and putting that into our long-term storage. But one of my coworkers, who is a lot more proficient with database stuff than I am, is writing pulling from blob storage in the database and transitioning that over. Now, what's really cool is she's actually going to use the service that I wrote. So it's pulling it out, putting it into a folder, and then my service is going to pick it up and move it as if it were a scanned file.
A regular submission. Yeah.
Yeah. So like I've already built that pathway. All she's got to do is put it into place for that pathway to pick up.
That's good.
But yeah, but we did that on purpose.
Yeah.
We occasionally have our moments of smartness.
Yeah. Well, like back in the day, if you had a big chunk of data, so like you would get stuff in a tab data stream out of SQL, but if you had a string in there that was too big for that thing, there was like an alternate way that you had to stream the data from the server.
Oh, wow.
And it was really like I did it once or twice and I was just like, nope, it's going in a file. If it's big, I'm done.
Yeah.
I wasn't good enough to pull that off at that point. Now, bear in mind, this was SQL 6.5 days. Like this was a long time ago. I still wouldn't do that generally with large records, especially if you have to index and search through the content, because a lot of the search capabilities of a relational database are just not built for this. Now they've added them. They've got full text search and things like that. But as far as just like the raw search where you're doing, hey, I want to see if this is like this thing. If you've got big chunks of data, it's going to be dog slow.
Mm-hmm.
The other thing is that typically if you're storing a lot of data, especially, large binary files or even structured text, even, like JSON type stuff, you probably like a like search is not going to work for what you want, right? You would go, oh, it's got this document and it has this XML down here underneath. And, you've got like a custom logic thing going on there. If you do it this way, you're going to have to implement whatever that is in SQL or use something pre-canned, which may or may not work, right? Like if I have a bunch of bitmaps in the database, how do I look at it and go, okay, I want all the bitmaps that have a 24-bit RGB bitmap with no alpha. And I want to do that in SQL. Like you can do it. You can, like in SQL Server, you can actually write C# code and host it inside SQL Server. Your DBA is not going to let you do it in an enterprise environment because you can bring the whole thing crashing down and
yep,
you just can't. So you're going to have to break the relational model in numerous ways here. It's not just, okay, here's the file. I may have to put some metadata for the file, or I may just put a path out here, and then I get some of the data from one place and I get some of it from somewhere else. And that's okay, because when you have a big record like that, that's your option.
Yeah. So another time when you need to break away from the relational model is when you have very sparse records with which most files are never queried. It's like sometimes you get records that potentially have hundreds of columns and most of them never get queried at the database level. You'll run into this a lot for things like setting values per user or tenant in a system.
Yeah, like if they don't override it and they just go, oh, well, if it's not overridden, it's null.
Yeah.
And then I just coalesce, and that's how I get my settings out. Like there's a crap ton of columns there, but most of them they're really sparse.
Yeah.
And so you have issues with performance should you try to query that because of it being sparse, and you just wasted a bunch of space, and it's kind of unwieldy to deal with. Now, that's not to say that you have to do this, but it tends to be a candidate.
Now, I would wonder if, I don't know, maybe there's probably instances where you can't do what I'm thinking, but like you could break these down into groups, like, and then if there's nothing connecting to another table, then it's like, all right, use the default. If there is, then you go to that other table and you get whatever it is from there to apply to it. I would think that would be possible in some instances, but as soon as I started talking about it, I thought of a couple where no, that really wouldn't work.
Yeah, it sounds great. You try to do it.
Yeah.
And then there's running and screaming. It's basically Jurassic Park. If you're not querying a lot of these fields directly and you get them all as a chunk, right? So like I want to get all the, file system settings for this service, for this, tenant, their use of a service, and you get them all in one shot anyway. Why is that in separate columns?
Yeah.
Like, why is that not just in a JSON payload? Because you're writing it to the database, and you're reading it from the database, and you're never querying it.
Well, this goes back to like if it's something like that, why don't you just have a document database?
Yeah. Well, I mean, this is a ghetto document database, right?
Yeah, like, true.
You do this to prove the concept, because a lot of times getting funding is the issue, is like getting somebody to pay for a document database when they don't understand what's going on. So you can do it this way and prove it out. The other thing is if you do have stuff that's sensitive like that, and it's, like giving a wrong value back to your app will break the app, you might not want the DBA to easily be able to go and edit that and do a bulk update or some junk and break everything. So you may actually want that to be in JSON or in a serialized, encrypted, byte array for that matter, right? Like it's entirely possible. One thing with sparsely populated tables that does tend to happen is that they tend to waste a lot of space. And if you do get somebody, who's decided that they need to index some of those things for like one operation, it gets to be kind of wasteful. And so this is a way of kind of getting around that sometimes. Now, another thing that's kind of similar to this is when your users come up with a schema for storing in your database, and they're like making custom records for stuff and things. Like they have like custom forms that live in your app. And there's, they lay out all the fields and they set the types and all this stuff. You've got to store that somewhere.
Yeah.
Right.
Again, a really good use for a document database, but
yeah, it is. Or you'll get an EAV type thing. So you'll have an extended attribute value table. So you have, whatever your default fields are, and then here's their crap that we never index because we don't know how to query it anyway.
Yeah.
But it gets really interesting trying to make a relational model for this type of scenario. And EAV will work for a long time, depending on how well you do it. There are sometimes issues, though, where it's really hard to index that cleanly, or where you have to allocate, huge amounts of space because there's one user that has a 4,000 character limit on some thing, and everybody else is like 15 character. And it's, it's really annoying to have to do. And it fails at scale. And you either have to get away from the relational model, or you have to just spin the ever loving crap out of it and say, okay, here's a reference to a file.
Yeah. Like I said, this is like a good use of something like a document database.
Yeah. Or an object, like there are object databases that can kind of handle some of these kind of things too, depending.
It depends on how you set it up, but yeah, I could see that.
Yeah.
So the next time that you would want to break away from the relational model is when your database is extremely read heavy on computed data. And we've kind of talked about some other instances where, like some specific instances where you're going to be read heavy, like historic data or for reports and things like that. If your database is getting hit with a lot of reads compared to the writes, and this is sort of like I said, this we've hit some specific ones. This covers the other instances of when that would happen, and having to do a lot of calculations, you can substantially lower the load by basically caching the calculations in a table.
Yeah, and this is really common in scenarios like content management systems, right? Because you got a whole bunch of tables. Like if you look at a WordPress post, have you ever looked at all the crap that's hanging off of that? Like go look at ours and cry.
Oh yeah.
And you're like, because I was looking at it going, I want to pull the data out of here and get it into a static site generator. And I'm like, I could do this in an automated fashion. And then I go look at that database and I'm like, Beach could do this in an automated fashion.
And then he said that to me and I just laughed at him. I'm like, nope.
I was trying to con you into it. It just didn't work. Okay. It's not my fault. I'm not convincing. I'm not a sales guy. Yeah. Now this is really helpful if the aggregate data doesn't have to be up to date. So I worked at a company that did content systems for news stations. And this was something we ran into a lot, right? Like if you have a snowstorm in the southeastern portion of the US, the traffic just goes through the roof. I can remember one day where we had a quarter of a record month's traffic in one day.
Yeah.
Like the spikes are crazy. And
you mean website traffic, not like driver traffic.
Right.
Because I was thinking when there's snow, there's no drivers out in the South.
Not any good ones anyway. There's a lot of off-road travel that is unexpected. And a lot of people, stepping up on bridges and like watching everybody crash. But yeah, you end up caching the crap out of stuff. And a lot of times you're like, hey, look, if this is 5 minutes old, I don't really care.
Yeah.
And so you end up doing that. So a lot of times, you'll kind of come into some similar situations, by the way, with reporting with this, where it's like, oh, hey, this report can be 24 hours out of date and nobody cares. But if the database is designed wrong, it can't.
Yeah.
It has to be up to the minute just because of the design. So, this is another scenario. Now, if you do need to update this stuff in real time, a lot of times you're better off updating it when data actually changes versus constantly recalculating. You still get a lot of savings by doing that.
It kind of depends on where you put your calculations too.
Yeah.
This is one of the conversations that I've been having at work recently with some of the stuff we're doing is like, all right, where do we want to put this? We know what needs to happen, but at what level does it need to happen? Like, does it need, it definitely doesn't need to be on the UI, but like at the API level or at the database level. And there's some stuff that they were surprised to hear me say, hey, that needs to be on the database. Because I almost always say, no, that needs to be at the API level. Because so much of the time it's rare that you have people trying to push database functions to the API. It's more often you have people trying to push business logic onto the database, in my experience.
Yeah.
And so
I'll agree with that.
I have surprised some people recently in some meetings I've been in where I've said, no, that needs to be on the database. Because they're so used to me saying, no, that needs to be in the API, because everybody wants to do the opposite.
Well, and there's a trade-off there, right? Because if you're doing aggregation, the further away from the database you are, it's cheaper to do that aggregation once you have the data there, but the transmission cost is higher.
Yeah.
Because you got to move it.
Yeah, and then that goes back to, all right, where's your cost benefit analysis? Where can you bite that cost?
Yeah, and if you're really clever, you can dump it out to the users and use their computer for it, which is surprisingly common.
Yeah.
So anyway, this is a thing that you'll kind of run into a lot of times. Now, here's another fun one. If you have multi-table constraints on your data, so you have business logic that, you're like, okay, this thing requires this thing and it's got to be in this format if it's this way, and, complex constraints, and then you break your database design up and that goes across multiple tables.
Mm-hmm.
It's harder to apply those constraints.
Yeah.
Like really complex ones. You can do foreign keys and crap like that, but the rest of it gets hard because you got to start messing with triggers and, detecting changes, and you get into a weird spot. So a lot of times you're better off if you just cram all that in one table.
Mm-hmm.
Even if relationally it's not necessarily the best way to go about it, but because of the constraints that you got to deal with, having it on a single table makes a lot of operations easier because you can handle it all in one trigger.
Mm-hmm.
You can do you can do calculated values. You can do check constraints. Those kind of things work on a single table.
Yeah. Now, the final thing we're going to talk about under reasons you would want to break from the relational model is when two types of environments require the same table. Sometimes you have a table that is getting heavy use for reporting purposes while also getting heavy use in a day-to-day transaction processing.
Yeah, and this one sneaks up on you because what happens is you design a system, you do it right, and then you leave the system alone for 5 years. And all of a sudden it just gets progressively slower. And usually the thing about it is like the speed of the system does not follow a linear curve.
Mm-hmm.
So as it gets slower, more load backs up and it spikes quickly.
I will tell you something that will help you with this if you have your developers writing your reports. So this is what happened to me. I had built out this system. I was working mostly on the API and sometimes in the database, designed and built out this system. Really good. Like great for reads and writes to it. But then we needed to start doing some reports. So I had to start writing the reports and building those joins and all that stuff. And I'm like, this is a pain. Give me a view to do this so it flattens it out.
Yeah. And you may actually physically want to move it to another table.
Yeah.
Because, like if you're getting a lot of transactions hitting it, you get locks. And it's very easy to get deadlocks. So I worked at a system where we had, a large number of what we call documents coming through the system. And it was basically like a document wasn't a document like you think of it. It's a set of values that gets mail merged in.
Yeah.
Give or take. And those tables got huge. They were also very wide.
Mm-hmm.
And what happens over time is that thing gets 1 billion rows in it.
Yeah.
Well, I think our biggest client had 250 million. And then you have somebody that's, and they're still cramming stuff in. And then you've got the guy that goes, hey, I want to see, do any of the columns have the word Bob in any of the data? And they hit it with a read, right? And it takes a long time. Now, on the web, that sucks. You can't get a good read. But the other problem was that there were some issues with locking that were occurring. And as a result of timing issues, there were deadlocks coming up. There were lots and lots of SQL timeouts. And by the way, these are in systems that you have a requirement to get stuff processed in a certain amount of time because of contractual constraints. Mm-hmm. And you have equipment that has to have that data in a short time frame, or the equipment's sitting idle because it's a factory floor.
Yeah.
And you got to start going, okay, I'm going to have to move, like this archive data needs to live somewhere else. And yeah, it needs to get updated, but that update is going to be kind of a deferred process that happens on a schedule after the fact so that everything can continue running because they have different load characteristics. And we really need to index the crap out of this one, but this other one needs to be just as fast as we can make it. We don't care about the index except for the field that says, hey, this has been archived.
Yeah.
So you'll run into that kind of stuff as you get under load and as your systems age, just because of the amount of data coming in. And it's not necessarily a reporting thing. It's just like, this is a functionality type.
Yeah. And like the whole point of relational databases is to avoid duplications until you need them.
Yeah, because, okay, so here's the thing with relational, is that design of systems came about when storage space was extremely expensive.
Mm-hmm.
And it just isn't now. And it also came about when the data sets were smaller, which
True.
is not now. Especially Internet of Things, when you get that, like the fire hose of 50 of these devices like barfing data at you constantly. You don't have small tables anymore. You can't do that.
Well, that's why we've moved. A lot of places that deal with that kind of data are moving towards NoSQL options.
Yeah, whatever that happens to be.
Yeah.
Sometimes like data lakes or, it kind of depends on what they're doing with it. The other thing too is a lot of times you'll take these tables and you'll actually put them on different physical media within the same server, so that one side getting under load doesn't slow the other side down.
That's smart. That's very smart.
I mean, you have to do that as a DBA with big systems. Like you start worrying.
There's a lot to being a DBA that as developers, we don't really see.
Yeah.
Because we're just like, hey, build me this table. Hey, do this for me, do that for me. And you don't really think about all the other things that they're having to do to administer and maintain.
Yeah. Well, we didn't even talk about backups here.
Oh, yeah. No.
And how those play into this.
Yeah, there's a lot to it, man.
Yeah. So the deal is that rules are made to be followed in general, but sometimes you have to bend them just to get by. And I suspect over time that the relational database model is going to continue to get twisted up like Gumby. It's not going to stay the same. You're not going to be able to be as firm at being able to say that, yes, this is the correct way to do this, because everybody's going to know of 100 places that that's not true. Especially true in computer science, that you just can't look at things that way. Rules are more like the pirate code. They're guidelines. They're not hard and fast rules. So that pretty much wraps us up. What do you have for us this week for Tricks of the Trade?
So I want to start off by saying we are not computers or robots. We've been talking about when to bend or break the rules in relational databases. I want to say rules exist for a reason. Typically, they're created for protection of ourselves or others. A lot of times that has to do with, what someone has done. I know Will and I have joked about like rules in the workplace coming around because someone did something stupid and things like that. The whole concept, like what I'm getting at here, is that there's a reason behind rules when they're made. There's a reason they exist. There's a reason that we have laws. Like there's a reason for the law. And when you understand that, what the underlying reason for the law is, you can understand when it's appropriate to not follow the exact letter of that law. I mean, it takes understanding and discernment, but we're able to reason and know what the underlying purpose or what the law is getting at. It's not the letter of the law.
It's the intent.
The intent. Yeah, that's what I was getting at, is the intent behind it. And when you know that, that's when you know how to apply it and how to bend it and how to, when necessary, break it.
Yeah, and you can do a cost-benefit analysis of what breaking it does for you versus not.
Yeah.
It's like speeding. Speeding is not a good idea, but if your wife's in labor and you got to get to the hospital, it suddenly becomes a very good idea, especially if you don't know nothing about birth and no babies.
Yeah, that's kind of what I was getting at, minus the whatever speak that was.
What movie was that from?
I don't know.
Was that Driving Miss Daisy?
Possibly. But basically, yeah, when you understand the intent behind the rule or the law, you know when it is okay to bend it and know when and how that it may be necessary to break it. And that's pretty much all I've got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.